Okay, here's another path counting question on a much larger grid. And we have 3 letters, so in this question, not only do we have to get from A all the way up to the finish line at C, we have to stop at point B along the way. So it's really a 2-part counting question. We first have to count how to get from A to B. Now, Pascal's triangle, that could work, but if you realize there's how many steps involved in getting from A to B, you'd have to go up 6 steps, at least at some point, and go over 10 steps. So that would mean we're going to be dealing with numbers in the 16th row of Pascal's triangle. Okay, so let's consider using Pascal's triangle, or Pascal's method. And you can see we have 10 rows in front of us here in this Pascal's triangle. And we also have the beehive appearance now. Quite often when we get into the higher rows, it's a little bit easier to see where the numbers line up if we use hexagons to outline those numbers. So if we were to consider going to the 16th row, of course that's not going to display on the screen, but we can fix that. You can see we're going down, and notice I'm keeping my eye on those diagonals till I see the number 16, and there's the very last row, the number 16, and we'd be dealing with numbers in the thousands. And so that's not really a good plan to count the number of paths to get from A to B, because you very well could be trying to fit in the numbers 560 and 1820 and 4368 on your tiny little grid. And the chances of an arithmetic mistake are pretty much guaranteed. So let's look at a more efficient way of counting this question. Of course, we'll use combinations instead. Okay, so to count the number of paths from A to B using combinations, we have to be aware that there are going to be 16 steps in total, and 6 of those would have to be in the north direction, and 10 of them would have to be in the east direction. So our counting problem is, of these 16 steps, how many ways could we choose, exactly 10 of them, to be east steps? And once we fill in 10 of them with eastern steps, the rest by default would have to be northern steps. And of course, another way of counting that is also to say, of these 16 steps, how many ways could we choose exactly 6 of them to be steps in the north direction? And you can see both of those are 8,008. Evidence again that we didn't want to rely on Pascal's triangle and Pascal's method to calculate the number of paths here. It would have taken a lot of time for sure. Okay, so now that we got from A to B, we still have to finish off and get to C. So please be aware that from A to B there are 8,008 paths, and those 8,008 paths can continue in a variety of ways from B all the way to point C. And one such example is those 8,008 paths could go 2 steps north, 2 steps east. Those 8,008 paths could continue 2 steps east, 2 steps north. They could zigzag 2 different ways. They could, those 8,008 paths could go a step to the right, 2 up, and 1 more to the right. And finally, those 8,008 paths have one last option, a northern or up step, 2 to the right in the eastern direction, and then finally 1 up. That means those 8,008 paths have 6 different ways that they can continue along from point B to point C. So those 8,008 paths have 6 different options to continue on from B to move and finish at point C. There's the first option, the second, third, fourth, fifth, and finally the 6th option. So if there's 6 options, those 8,008 paths have, and the total number of paths to get from A to B and then finally to C has to be 8,008 multiplied by 6, or 480,048. Okay, let's refine the previous approach just slightly. Instead of tracing out the paths, which you can see in the gold section here, with 6 different colors outlining 6 different paths, we're just going to count those paths instead. So we know we have to count the number of paths from A to B. And then once we establish that, which of course is 8,008, we now know we have to just multiply that by the number of paths to get from B to C. So that would mean to count those number of paths in the gray section, that's either 16 choose 6 or 16 choose 10. either one works fine. Each will give you 8,008. And remember, by me saying 16, choose 6, I'm saying of those 16 steps to get from A to B, I'm choosing exactly 6 of them to be steps in the northern direction. And instead of tracing out the 6 steps, it makes a lot more sense possibly just to count those. So to get from B to C, there's 2 steps to the right and 2 steps up. That's 4 steps in total, and we have to choose exactly 2 of them to be either up or to the right. It makes no difference there due to your symmetry in the combinations. And if we understand that that needs to be multiplied, and that's why I did it the way I did previously in the video, is to really show you that those 8,008 paths have 6 different options, which means the fundamental counting principle is kicking in here, and we have to multiply those 2 total number of paths together. So the number of paths to get from A to B multiplied by the number of paths to get from B to C. And we can use our fancier combination notation, and if you punch that into your calculator, you will get 480,048, and you won't have to trace out any paths. You can count that very quickly and efficiently.